Let's learn how to use Convex in a Remix application by building a real-time to-do application. I know to-do apps are kind of like the hello world of the development education area. You don't really want to do it because it's a relatively overdone concept, but it gets a lot of points across, and I really think a to-do application to learn how to use Convex and Remix is a really good starting point. Convex is a really cool backend-as-a-service service that takes your backend to a whole new level by enabling real-time functionality in applications using subscriptions to the backend Convex service. What this means is that if you have two users that are looking at the same data, when one user updates the data in their client, the other user is automatically going to see the updates in the device that they're using. This is the second in a series of videos I'm creating teaching you how to build a real-time to-do application using a combination of services and frameworks such as Remix, Convex, Fly, Clerk, and Live Blocks. A link to the playlist for the entire series will actually be in the corner of one of the corners of this video. And with all that, we're going to start by using the Convex CLI to create a Convex project and optionally create an account if you don't already have one. Let's jump in. All right, so I have the integrated terminal open on my computer within VS Code, and we're going to start by running the command npx convex dev. What this is going to do is if you already don't have an account set up with Convex, it's going to walk you through the process of creating an account, as well as authenticating your local machine into the Convex service. I already have an account, so it skipped that process for me. I'm going to go ahead and press Y to proceed with executing the convex dev command. And it's going to prompt me to either create a new project or choose an existing project. This is the first time I am using it for this specific project, so I'm going to go ahead and create a new one. It's going to default to the name of Remix To Do on Fly, which is the name of the folder on my computer. And then it's going to go ahead and create our specific project up inside of Convex. Now you'll notice you get an error. It says, in order to push, add Convex to your package.json. And this just means that we need to install Convex into our project. So I'm going to run Control-C to cancel that npx convex dev because we're going to have to run it again. And I'm going to run npm install convex in order to install the Convex dependency inside of my project and run npx convex dev one more time. Now we should get a message that says Convex functions are ready. And essentially what happened when running npx convex dev is on top of creating the project inside of Convex, it also adds this Convex folder to our project. Close up some of these other folders here. And you can see there is a tsconfig, a readme, and then a generated folder. This folder is going to install our queries and mutations, which are the ways that we can access and manipulate the data within the database inside of Convex. And what the convex dev command is going to do is keep our local machine and the definitions for our queries and mutations synchronized with the Convex service at all times, so this way we can properly develop on top of the service. So what we're going to do here is create the necessary queries and mutations in order to add and list tasks within the to-do app we're building. So I'm going to right-click and create a new file inside of the Convex folder, and we're going to call this tasks.ts. I'm going to close out this terminal here so we have a little more room to work, and we're going to import a few things. The first thing we're going to import is v, which is a way that we can type our Convex queries and mutations, and that's going to be imported from convex/values. And then the next thing we need to import is the mutation function and the query function, which is going to be imported from that generated folder. So /generated, and then select server from the autocomplete here. Now let's start by creating a query that's going to let us list tasks. I'm going to export const list tasks is the name of the function that we're going to use. And then that's going to be equals to query. And then inside of the query function that we imported, we're going to pass in an object. The object requires you to have one handler function, like so, and then that's going to be an asynchronous function. We're going to pass in CTX, which is the context for the Convex connection, and then that's going to be passed into an arrow function. And then finally, in order to return a list of tasks from the tasks table inside of the database, we can simply return await ctx.db.query. We're going to pass in the name of our table here, which is tasks. And then we're going to go ahead and end with .collect, which is essentially going to select all of the records from that table. And this is essentially all we need to do to request data from the database within Convex. Now let's go ahead and add another function, which is going to be a mutation that lets us add a task. So I'm going to export const add task is going to be the name of our mutation. We're going to pass in that mutation function that was imported, and this also is going to take in an object as its parameter. Now instead of just the handler, in order to pass values into the mutation, we need to define the args field. So I'll type in args. That's also going to be an object. The name of our argument we're going to pass in is going to be task name. And then we're going to set that to a type of v.string, which is essentially telling the overall system that we should expect a string value to be passed in as an argument, which we'll see once we populate out the actual Remix portion of this application. This is also going to take a handler. This is also going to be an async arrow function, just like we defined above, except instead of just including the CTX, we're also going to include args, which is going to give us access to the defined task name within the arguments. So I'll finish off this arrow function, and then we're also going to await ctx.db, but instead of query, we're going to run insert. This is going to be on the tasks table as well. And then the insert function accepts a second parameter, which is going to be an object that contains the column names and the values that we're going to be inserting inside of that. So I'm going to set the column of task name to be equal to args.taskName, which is essentially going to take the value passed in from this section of the mutation and pass it into this section of the mutation inside the handler. And with that, we have a very basic query and mutation, which lets us both add a task and then list out the tasks that have been added into the database. So as mentioned, Convex is a real-time data platform, and in order to get that real-timeness of Convex, what we have to do is actually update the root.tsx file of our Remix application and wrap the entire app inside of a Convex provider. So let's go ahead and do that now. The first thing I'm going to do is import a couple of new things. So we're going to import Convex provider and Convex React client. And that's going to be imported from Convex/React. Like that. And then the next thing we need to also do is import useState, since we're going to essentially set the client to a state object in React. Convex uses an environment variable in order to connect to the proper backend instance. So we're going to add that environment variable into some loader data. So let's create that loader now. We're going to export async function loader, and then we're going to parse out our convex URL. So convex_URL is going to be equal to process.env, and then open up some square brackets and then type in convex_URL in order to pull that from the environment variables. And then finally, we're going to return JSON, and then inside the JSON, an env object, and that's going to be our convex_URL. Now, JSON is not imported yet, so let's go ahead and import that from remix run/react, like that. And then down inside of our layout, let's go ahead and say const, open some brackets, env is going to be equal to use loader data. In order to get that loader data, type of loader. And next, let's create the Convex React client and then add it into a state object. So const, open square brackets again, convex is going to be equal to useState. And then we're going to pass an arrow function into useState and say new Convex React client. And then in that, we're going to pass in the env.convex_URL, just like that. Now, we also have to import use loader data. So let's go ahead and paste that into the imports from remix run/react again. And now let's go ahead and wrap the children object of our body here inside of that Convex provider. So I'm going to get rid of children temporarily. We're going to add we're going to type in Convex provider, and then the client is going to be equal to the Convex state object that we just created earlier. And then finally, we will add our children back in, just like that. Okay, at this point, the entire application is now going to be wrapped inside of that Convex provider, so we can start adding our mutations and queries into our pages in order to take advantage of Convex. And we're just going to modify the index page in order to add some basic to-do list functionality. So I'm going to go ahead and open up index from my routes folder. And I'm going to close out my sidebar just to get a little more space to work with here. And all of our modifications at this point are going to be done inside of this file. Inside of our return, we're going to actually clear out everything inside of the outermost div, so we have a clean slate to start with. Let's go ahead and start by adding an input in here. Now, I have shadcn installed and configured inside of my project already, which is why I can import an input property, but any import is going to work. This just gives it a little more styling here. And then for this input, before we continue building it, what we're going to actually do is define a state object that's going to hold the value of that. So const task name, set task name, and that's going to be equal to useState. And then we're going to give that an empty string just to start off with. And then now inside of input, we can set the value equal to task name. And then on change, we're going to take our event and set a arrow function to set task name of e.target.value. This is essentially going to bind the input into our task state up here. So this way, when we change the text inside the field, the text inside of the use state is going to change as well. Next, let's go ahead and create a button. Same thing. I have a shadcn component here, but you can use any button will work just fine. We're going to add the text of save inside of it, and then on change, we're going to create a function named onSaveClicked. Now let's define our function. We'll say async function onSaveClicked, and we're just going to leave this empty right now. Now, before we can actually save the task, we need to use that mutation that was created earlier. So we're going to say const add task. Mutation is going to be equal to use mutation, which is a hook from Convex. You can see my autocomplete is already importing it from Convex/React. In fact, towards the top of the page, you can see use mutation was imported from Convex/React. So if you need to do that manually, go ahead and do it now. And then we're going to pass an API.tasks.addTask. Now this is going to have a red squiggly here. What we need to now do is import API from that generated folder of Convex. So in my imports, I'm also going to import API from convex/_generated/API. Now using the mutation is relatively simple. We're going to await add task mutation. And then we're going to pass in our parameters as an object. So our task name, which is the argument from the mutation itself, is going to be set to task name, which is the value of the state object. And then next we'll reset the value of that task name state object by setting the task name to an empty string once again. And this essentially lays the groundwork for us to be able to add tasks into our database. So I'm going to open up my terminal again, and we're going to create a new terminal window. It's important to know that if you're building something with Convex, you need to have this npx convex dev running at all times so it can continuously sync up your code with the Convex service. But in this other terminal, I'm going to type npm run dev, which is going to start up my Remix project. And then I'm going to head to my browser where I have the actual application open. Now you can see it doesn't look the cleanest. Let's actually head back in here and let's add a little bit of padding in here. So I'll just type in P4, which if you're familiar with Tailwind, adds a little bit of padding to the outside. And now we can see here's our input box and here's our button. I'm going to say hello world for my task name. We'll click save. And that turns out nothing happened because I actually made a slight error in this button. Instead of on change, this should be on click. I'll click this button again. And although it seems that nothing happens except for the text going away, we actually already sent that data into our Convex database. So now that our data is saved into the database, let's go ahead and take advantage of that query that we defined earlier in order to render a list of tasks below. So I'm going to go back into VS Code here. I'm going to close my terminal here just to get a little more space. And then inside the header of my function, I'm going to also type in const. And then inside the header of my function, I'm going to use the useQuery hook from Convex in order to query data. So I'm going to say const tasks is going to be equal to useQuery. And this is also being imported from Convex/React. And let's pass an API.tasks.listTasks. Now, when this page loads, this line here is actually going to fetch the data from Convex. So we don't actually have to await the data being returned from the service. This is going to take care of that for us. But inside the return, let's go ahead and add the logic to render the data from tasks. So I'm going to create a new div tag here just to create a container to hold the information. And inside this, we're going to run tasks.map. We're going to also add the question mark, which is going to check to see if tasks is an empty object. Otherwise, this process will be skipped. This kind of saves us from any kind of errors occurring on the page. And then from there, we're going to map each one of these tasks into another div. We're going to set the key to this div to t._id, which is the unique identifier that's automatically created for the task inside of Convex. And then inside of that, let's go ahead and close out my div tag. We're simply going to do t.taskName, which is the name of the parameter from our mutation. And that maps to the name of the column inside of Convex. So I'm going to go ahead and save this. Back in the browser, you can see we already have hello world added here. In fact, if I add another task here, I could say foo and then hit save. And it's already added in here. Now, what's really cool about Convex, and I want to call this out, is we don't actually have to manipulate any kind of state once the task is named. Traditionally, inside of a React application, you would use an API to save the data and then have to either re-query the data to re-render the list or dynamically inject it inside of a list that's already inside of a state object. In this case, Convex kind of takes care of all that for us, so we don't have to write any of that code and handle this manually ourselves. So now that we can see data being added, let's go ahead back into our tasks.ts file, and we're going to add a mutation that's going to let us complete and uncomplete tasks as needed. So we're going to export const set task state, and that's going to be equal to another mutation. We're going to accept a set of args here, and then we're going to set two parameters inside of our args. The first thing we're going to do is we're going to accept the ID of the task, and that's going to be a string value. And then we're also going to accept a Boolean of is complete. And we can set this as a Boolean with v.Boolean. like that. I'm going to create my handler here, which is also going to be an async arrow function that's going to take in our context, our CTX, and then also our args. That's going to pass into an arrow function again. And then we're going to use the patch function instead of either query or insert. So I could say await ctx.db.patch. Now, what's very interesting about Convex is the ID is associated with a specific record inside of a specific table. So as long as you know the ID of the object you're trying to manipulate or delete in that case, you can simply pass the ID and not worry about passing in the name of the table itself. So I'm going to say args.id. And this will error because we set it as a string, but if we cast this to an ID value, which is going to be imported from _generated / data model, Convex will recognize that this is indeed the ID of a record instead of just a string value. And then we're going to pass in the changes to the data. So I'm going to type in isComplete, which is the field name that we want to modify, and then args.isComplete to pass in the actual argument that's being sent into the mutation. Now, the other notable thing here is when you use db.patch here, you don't have to specify any existing data. What patch does is simply change the values of the columns that you pass in. So anything that's already inside of the task object, in this case, we also have a task name field, that is going to stay the same. So we just have to pass in the data that needs to be changed. And with that, our mutation is done. Let's head back into the index.ts file and pull in our mutation. I'm going to add a new line here and say const set task state mutation is going to be equal to use mutation, and then api.tasks.set task state. Let's go ahead and create another function here, which we're going to use to wire into a button for each one of the tasks. I'm going to say async function, toggle task state. And this is going to set an ID of string, and then an isComplete of Boolean. And then we're simply going to await set task state and pass in our ID, and then pass in our isComplete. Sorry, this should be task state mutation. Now we get red squigglies here just because my toggle task state is not currently being used, but let's go ahead and modify the field down here in order to do that. So instead of typing all this out, I'm actually going to paste in some updated code for this loop that's happening here. And what this is doing is simply adding a little bit of styling to the div, and then we're going to add a button here that is going to either render a square with a check mark in it if the task is complete, or just a square if it's not complete. Kind of simulating the checkbox inside of a task or to-do apps, where if you check the square, it either shows with a check mark or not. And then on clicking that button, we're also going to leverage our toggle task state, passing in our ID, and then we're also going to go with the opposite of whatever is complete of the current task. So if the task is currently complete, it's going to pass in false. If it's not complete, it's going to pass in true, thus setting this task state properly. So with that code added, let's go ahead and back into the browser, and you can see that each one of my list items has this button that's rendered next to it, and I can click it in order to set the task state. And then if I refresh my page, that data is retained, and we can also click it again to uncomplete the task. And now finally, to round things out, let's go ahead and add another mutation to delete a task. I'm going to go ahead and add a new line here, and I'm going to say export const delete task. We're going to create a new mutation. For our args, we're simply going to pass in an ID, b.string, just like we did in the previous example, and then we're going to set our handler here. And then we're going to await ctx.db.delete, and then pass in our args.id as ID, just like that. And with the delete task mutation done, let's go back into index. We're going to add that mutation in here as well. So we'll say const delete task mutation is going to be equal to use mutation, and then pass in api.tasks.delete task. Okay, I went ahead and pasted in the code here again, which is simply rendering another button that contains a trash icon inside of it. And then I've also added the group value to Tailwind. And all this does is just add some fancy styling. So this way, the delete button is not shown all the time, but it is when we hover over the button. And now when I hover over either one of these tasks here, you can see there's a delete button that shows as well. If I click on that button, the task is completely deleted. If you like this kind of content, just a quick reminder, share it with somebody, like the video, and subscribe to my channel if you want to see more like this in the future. See you soon. Bye-bye.